We often picture chemistry as something totally confined to laboratories, right? You probably picture complex equations, crisp white coats, maybe a bubbling geeker or two. But honestly, the truth is so much cooler. There are these fascinating, entirely invisible chemical forces shaping literally absolutely everything around us. We're talking from the vastness of the universe all the way down to your own body. So, welcome to this explainer. Today, we're going to uncover the essential marvels of modern chemistry that are just hiding in plain sight.
So let's kick things off by looking inward. Let's ask a pretty fundamental question about our own existence. If we were to break you down to your absolute most basic components, what is your body actually made of? It's a question philosophers have agonized over for centuries, but, well, chemistry actually gives us a remarkably precise and kind of surprising answer.
All right, Section 1. The chemistry of you.
My mass, you are essentially a walking, talking chemistry experiment. You're overwhelmingly made up of just a few basic elements. A massive 65% of you is just straight-up oxygen. Carbon comes in second at 18%, followed by hydrogen at 10% and nitrogen at 3%. Everything else, all the calcium in your bones, all the iron in your blood, that all fits into that tiny little 4% sliver we call other.
Now, the absolutely crucial point here is that 18% slice of carbon. Carbon is incredibly special. It has this totally unique ability to bond with itself and a bunch of other elements, which allows it to form literally millions of different compounds. This insane versatility makes carbon the absolute basis of organic chemistry. Simply put, without carbon's unique structural flexibility, life, and yeah, that includes you, just wouldn't be possible at all.
Okay, moving right along. Section 2. Everyday Molecular Mysteries.
1.76 trillion. That is a 1.7 followed by 21 zeros. Just think about the sheer, mind-boggling scale of water for a second. That massive number, that is the exact number of water molecules crammed into just a single tiny drop. It really puts into perspective just how microscopic the building blocks of our world truly are.
And water gets even weirder. Almost every single substance in the universe follows a pretty basic rule. When it cools down, it shrinks, it gets denser. But water completely defies the rules. It actually expands by about 9% when it freezes. And that little molecular quirk is exactly why ice floats in your glass instead of sinking straight to the bottom.
Or take a diamond. It's one of the hardest materials known to humanity. Now compare that to graphite, which is so soft it literally flakes off to help you write with a pencil. The really mind-blowing fact here, they are both made entirely 100% of carbon. The exact same atoms create both an unbreakable gemstone and the soft lead of your pencil. It's dictated entirely by how those atoms are arranged.
Now, let's move over to your window pane and see how this builds our understanding of everyday objects. You've probably always thought of glass as a solid, right? Well, actually, scratch that. Chemistry tells us glass is kind of playing a trick on us. It is not a true solid. It's what we call an amorphous solid, because, unlike ice or diamonds, its atoms completely lack a regular, repeating crystal pattern.
All right, let's switch gears. Section 3. The elements of surprise.
Imagine holding a piece of solid metal, and right before your eyes, it just melts into a puddle right there in your warm palm. No way, right? Well, that is gallium, which has a melting point of just 29.8 degrees Celsius. And then we have mercury. This is a metal that doesn't even need the heat of your hand. It is literally the only metal that is naturally a liquid at room temperature.
And the surprises just keep coming. Did you know your morning fruit is radioactive? Seriously, bananas contain a naturally occurring radioactive isotope called potassium-40. But don't panic, it is completely safe to eat. Then consider gold's insane malleability. Just 1 single gram of gold can be beaten so incredibly thin that it covers nearly a square meter. And on the more aggressive side of things, we have fluorine. This is the most reactive element on the periodic table. It practically refuses to be left alone and will react with almost everything it touches.
Now, if we zoom out to a universal scale, the distribution of elements is just as fascinating. Hydrogen overwhelmingly dominates space. It makes up about 75% of the universe's ordinary matter. Meanwhile, helium was literally hiding out in the stars. Scientists actually discovered it by observing the light of the sun before it was ever even found right here on Earth.
Okay, final part. Section 4. Sensational chemical reactions.
Think of that amazing, earthy, fresh smell right after a summer storm. You know the one. It's so distinct it actually has a name, petrichor. But that scent isn't just water hitting the dirt. It's a very specific chemical cocktail. When rain falls on dry soil, it kicks up plant oils and a compound called geosmin, which, get this, is actually produced by soil bacteria. So you are literally smelling soil chemistry in action.
And to add to that whole sensory experience, lightning plays a massive role in the smell of a storm, too. The immense electrical energy of a lightning strike literally splits oxygen molecules right up in the atmosphere, creating ozone, or O3. That ozone contributes heavily to that unmistakable, sharp, almost clean scent lingering in the air after a heavy thunderstorm.
And what about what we see? Chemistry is directly responsible for the dazzling visual colors of fireworks. We're not talking about paint or dye here. It is pure elemental combustion. Each specific element burns a very distinct hue. Strontium burns a brilliant red, sodium lights up yellow, copper produces blue, and barium explodes in bright green. Basically, the sky on New Year's Eve is just one giant floating chemistry demonstration.
Behind the scenes of so many of these reactions are some fascinating mechanical rules. For instance, you have catalysts. These act like tiny chemical matchmakers, speeding up chemical reactions without ever being consumed or used up themselves. And then we have the pH scale, which measures acidity. Now, this is logarithmic, not linear. That means a solution with a pH of 3 isn't just a little more acidic than a pH of 4, it's 10 times more acidic. And it's 100 times more acidic than a pH of 5. Just a tiny number shift means a massive leap in reality.
118. That is the total number of confirmed elements currently sitting on the periodic table. That's it. Just 118 building blocks that mix, match, bond, and react to create literally everything around us. From the food we cook and the air we breathe, to the batteries, the medicines, the cosmetics, and the very smartphones or computers you might be using to tune in right now.
So, I'll leave you with this final thought to ponder. We've seen how chemistry isn't just a boring subject stuck in a textbook. It's the dynamic, completely invisible machinery running our reality. With chemistry shaping everything from the screen right in front of you to the very breath in your lungs. What invisible reactions are happening around you right now? Keep your eyes open, stay curious, and you'll start seeing the magic of chemistry everywhere you look.